Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about how to calculate lambda max for unknown system using Woodward and Fisher rule. That are the point we were discussing. So what we are going to discuss today, we are going to solve some of the problem based on the unknown system. As we know that here are two systems. One is a dyne system and one is a unknown system. What do you mean by the dyne system? What do you mean by the unknown system? What are the base value for dyne system? What are the base value for unknown system? And how to identify exocyclic double bond in dyne system as well as in a unknown system. Similarly, how to identify Homo annular system present in a dyne system as well as in unknown system. Another prominent point we are identifying, that is extended conjugation. What do you mean by extended conjugation? How to identify it? How much to add in a lambda max? That are the point we already discussing. And then last one is a substituent. How to calculate, how to count substituent for dyne system as well as how to count substituent in a unknown system. Are they same or different? All these minute differences are the point which are required for dyne system as well as unknown system. At the basic level we have discussed so clearly, there is no doubt regarding those points. On the basis of that, now we are going to solve some of the problem which is based on unknown system. Let me draw the molecule first over here. That is, I think we have solved so far 4 compounds. We had calculated lambda max for those 4 compounds. Now today we are going to calculate the lambda max of the remaining compounds so that you can get familiar with those problems and you will try to solve these problems using our standard formula, and that is my what we can call it as a business here. Now let me draw the structure, that is a structure number 5 which I am drawing over here. So let's see, this is a structure which I have drawn over here. This is a structure. Here I am putting one of the substituent which is OH. Here is a methyl group. Now here this one and double bond is over here. So this is the, now one more, yes, this is a methyl group over here, or you can show only as a stick. It doesn't change. If you observe this structure carefully, first observe the structure carefully and identify what type of the system it is. As I already told you, there are two systems. One is a diene system, another one is a enone system. Now tell me, what type of the system here? Is it diene system or is it enone system? Look at here, this is a carbonyl group, single bond, double bond, and therefore it is definitely the enone system, right? Once you identify enone system, so you can circle it like this, and then once it is a enone system, now focus the carbonyl group, whether it is attached to, because in a enone system, how much is the base value? There are 3 different base values for enone system. Suppose carbonyl group attached to 6-membered ring, or there is a alkyl group, if it is an open chain, then we must consider the base value 215 nanometer. Suppose the carbonyl group attached to the 5-membered ring, then you must consider base value for it 202 nanometer. If the carbonyl group, there is a hydrogen atom, means aldehyde group is present, then you should take the base value 207. So there are 3 different base values. One is a 215 nanometer, second one is a 202 nanometer, third one may be as a 207 nanometer. These are the 3 different base values for enone system. Which base value we should take, we should consider while solving this problem. So as the beginning, as I already told you, that this carbonyl group, focus on that carbonyl group. This carbonyl group attached to the 6-membered ring, and therefore base value must be the base value. And now first one, while solving the problem, you should write it like this. It is a enone system. It is an enone system, not a. There is some grammatical rules you can follow here. It is an enone system, right? Once it is a enone system, what should be the base value? Base value should be 215 nanometer. 215 nanometer, it will be the base value for this. And now, what is, as we know that, what is our standard formula while solving this kind of problems? Base, BESS. B stand for base value, just now we have wrote here. Now E stand for exocyclic. Now first label the rings, or if you count the rings, you will find there are 4 rings. So you can give A ring, B ring, C and D. There are 4 rings. Now, as I already told you, the easiest way to identify exocyclic double bond. What do you mean by the exocyclic double bond? means the ring which is having outside the double bond, but that should be in a conjugation, then and then you can consider, it can be considered as an exocyclic double bond. Otherwise, if it is not the part of the enone system, it is far from conjugation, then it is not considered as a that exo double bond. Now look at here. If you put hand on A, what do you observe? Here are 1, 2, 3. These are the outside bond. One carbonyl is there, but don't count. Carbonyl is always outside the ring, and therefore you should not consider it as a exo. So here, if you put hand here, that is the easiest trick I already told you while solving the problem. Now, you never see here exocyclic double bond present for ring A. Now put hand on B. What do you observe? You can clearly observe here there is a one exocyclic double bond present here. In A ring there is a one bond which is outside the ring of B, and if you put hand on C, you will find there is a no double bond outside the ring. If you put hand on D, you won't observe any double bond outside the ring. So in this way, we have identified exocyclic double bond in this particular compound. How many exocyclic double bonds are? We recognize here are only one exocyclic double bond. So you can write here one exocyclic double bond, exocyclic double bond. If one exocyclic double bond is there, how much nanometer to add in it? You should add 5 nanometer in it. Now another third letter H. What does it? H indicate homoannular system, and as we know that homoannular system means what? If both the double bonds, again listen carefully, both the double bond present in the same ring which are in conjugation, then and then it is considered to be homoannular system, otherwise it is not. So if you observe here, there is no such condition. You can see here only one double bond which is present in ring A. So there is no question of homoannular system present in this case, and therefore there is no need to add, no need to write here homoannular system, so neglect it. Now the fourth letter again E stand for, it is a different than the previous E. Previous E suggests that exocyclic double bond, and this another fourth letter E suggests that, indicate that is a extended conjugation. Extended conjugation is nothing but extra double bond. Excluding, I am saying excluding the conjugation that is there, and therefore E stand for extended conjugation. Look at here, only as a enone system is present, there is no extra double bond present in this compound, and therefore there is no extended conjugation present over here. No need to write that point over here. So let's see, the last one is a substituent, and it is a very significant as far as most of the students get confused when they considering the substituent in a diene system or in a enone system, while in a enone system always designate this is a carbonyl group. Adjacent carbon atom is always termed as alpha, and look at alpha, there is no substituent, only hydrogen atom is present, and as we know that if hydrogen atom is present, there is no need to add any nanometer, 0 nanometer, so don't write over here. Now if you look at here beta, this is a next carbon atom is termed as a beta, and next carbon atom beta, then is there any substituent present at beta position? Yes. If you observe carefully, you will find one is here, another is here. So there are two beta substituents present in this case, and therefore you can write here the substituents two beta. So for one beta we generally adding 12 nanometer. If 2 is there, 12 into 2, it becomes as a 24 nanometer, and then you can mark it, write it like this, lambda max, and then do the addition over here. After doing the correct addition, you will find here 5, 5, 10 and 4 is 14. So 4, there is a 1, 3 and there is 4. So now is a 4 over here and 2 as it is. So total becomes as a 244 nanometer, which is the lambda max of this compound. Do you got it? So in this way we can solve the problem based on UV. Is there any difficulty while solving such problem? I hope you all are getting better and better. So you will find it is easy to solve the problem. And now, and I already told you that there is no need to remember all these values. They are already provided in the table which are separately attached to the question paper in annual examination. If you had seen that annual examination question paper, you will find there are the 3 tables attached to that question paper. One consists the value of stretching values of IR frequencies, and second would be the chemical shift value delta, which is given in ppm, or third value for UV for diene system as well as enone system separately are given. You have to just overlook it and try to solve the problem based on it. Now let me give one more example over here, the example number 6. Now example number 6. So let us see over here. This is a problem which is given over here. Now see this problem carefully. I am putting, these are the substituent attached to this. Look at this. Now what is our first job to do, or first business to? First you have to identify the system, what kind of the system at T.Y.B.Sc level, there are only two systems are there. So both these systems are very easily we can identify. So if you look at within a fraction of second, you can identify the system very easily. There is a carbonyl group, single bond, double bond. So you can mark it like this and you can write it the one sentence while solving the problem. You can write it, it is an enone system, right? It is an enone system. And once it is an enone system, what should be the base value? You think little bit over here. You don't take as a burden over here, but you look into the table and then remember for enone system there are the three base values. Which base value you should take, that decided how much you are knowing about that UV spectroscopy, and therefore the base value for this, because that depend upon there are three base values, one 215 base value, another one 202 and another one 207. If that Z is equal to hydrogen aldehyde group, this is for CHO group, and as we know that CHO group is always present at the end of the ring, and where this is for 5-membered ring and this value for 6-membered ring carbonyl group, and then suppose there is a R group, Z is equal to R. So these are the point you should remember while solving the problem based on. If you see over here, this is a 5-membered ring, and once you identify 5-membered ring, then the base value should be 202. Those are student written as a base value 202. They will get whatever mark allotted to that question, they will get as a full mark. And if you are those students are writing as a base value 215, they will get as a 0 mark, because they are totally not aware of that the base value. There are the three different base value for enone system. Let us see over here the base value for this is a 202 nanometer. Why 202? Because it is a 5-membered ring, carbonyl group is attached to 5-membered ring, then the base value should be 202. If carbonyl group attached to 6-membered ring, then base value should be 215 nanometer, as we know that. And now second one, E. E stand for exocyclic double bond, and as we know that is there ring present in this compound? Yes, it is a ring, so only one ring is present. You can label it as a ring. Then put hand on A ring. What do you see? There are different substituent. One carbonyl group which is always outside the ring. Don't consider it is a exo. So there is no exocyclic double bond present over here. Now third letter A stand for homoannular system. Is it homoannular system present in this compound? No. And homoannular system, as we know that according to the definition, both the ring should present in the same ring, and which is alternative. But only enone system is there, no other ring, no other double bond found in the same ring, and therefore there is no question of homoannular system. There is no homoannular system in this case. Next one, E stand for extended conjugation. If you observe this structure carefully, if you put only enone system is there, no extra double bond present over here, and therefore no question of extended conjugation. Now just substituent. While substituent, always remember this is a carbonyl group, this is adjacent carbon atom, this is also as an adjacent carbon atom. But which way we should go? We should go to we should follow the path where the conjugation, where the chromophore is there, that way you should label it. Don't go other side. This one also has adjacent carbon atom, this one is also adjacent carbon atom, but don't go this way. Don't label this. But this is there, and therefore you can label it. It is alpha. Always adjacent carbon atom next to the carbonyl carbon atom, it is designated as alpha. And now see here one stick you can clearly see here, which is nothing but as a alkyl group. If alkyl group present at alpha position, now we are right here substituents. Now at alpha position, one substituent you can clearly see over here. So how much to add? You should add 10 nanometer in it. Now next carbon atom, which is designated as a beta. Now count how many beta substituents present over here. One is a ring residue, another side is a alkyl group. So here you can see 1 and this one is a 2, means there are 2 beta substituents, as we know that. So 2 beta substituent, and as we know that 1 beta means 24, and now 12 into 2 it becomes as a 24 nanometer, and therefore you can write it like this: lambda max is equal to, it becomes 0, then 3, and that 236 nanometer, that is a lambda max for this molecule. So in this way we can easily find out, we can easily count the number of substituent in this way we can easily calculate the lambda max of the following compounds. So far we have solved 2 problems. Let us see one more problem over here, that is a problem number 7, which we are going to solve over here systematically once again. So this is a problem number, what we can call it as a 7 over here, and the structure which is given over here, let's see. This is a structure. Now here C double bond O, one double bond here, another one, there is a one bond over here, another bond over here. So this is there, and these are the problem which are generally coming in the exam. So that problem I am trying to solve. I am solving over here. Now if you observe this structure carefully, what do you find? What type of the system it is? If it is a carbonyl groups are there, then always consider it is a enone system. It is in the conjugation. But here if you some of the student may think that there is a diene system, don't consider like this. If carbonyl group is present and which is in a conjugation, then always consider it and always said it is a enone system. Don't get confused over here. So this you can label it, here is a enone system, and therefore as usual we can write it as it is an enone system. Enone system, right? It is an enone system. Once you written like this, enone system, as we know that there are 3 base values. Which base value we should take? We should write here, which is important. Now look at this carbonyl group attached to 6-membered ring, and therefore we can easily find out the base value for this is a 215 nanometer, right? This is a 250. Now E stand for exocyclic double bond. Is there ring present here? Yes. Look at here. If you observe this structure carefully, you will find there are two rings. One ring we can call it A ring, second ring we can call it as a B ring. Why labeling is necessary here? There is it will help you to calculate the lambda max very accurately, very precisely, and that's why it is needed. Now, what is the next? E stand for exocyclic. As we know that if you put hand on A, what do you observe? Look at here, one outside double bond is there. Don't consider carbonyl as a exo, but here one exo is present for ring A. Now put hand on B. What do you observe? Look at here, this double bond is outside the A ring, and therefore total number of exocyclic, A ring having one exocyclic, B ring also has one exocyclic, total becomes as a 2 exocyclic. So here exocyclic double bond 2 into 5, it becomes as a 10 nanometer, right? So 1 exo means we should add 5 nanometer in it. Now H stand for as a Homo annular system. Look at this structure carefully. What do you observe? There is an Homo annular system means both the double bonds present in the same ring. This double bond A ring, B also contain as a one. So there is no Homo annular system. So there is no need to write Homo annular. Now is the extended conjugation. Is there extended conjugation present in this structure, in this compound? Yes. Look at this is a diene system and this is an extra double bond present, and therefore here you can write extended conjugation, and if extended conjugation is there, you can add how much nanometer? 30 nanometer. So you can add over here 30 nanometer in it. Now 30 nanometer, after that what you have to observe? What is the next point? E now is a substituent, and as we know that here while counting as a substituent, first label the adjacent carbon atom, as we have seen while studying as a basic thing. Look at this is a carbonyl group, adjacent carbon atom, it is termed as alpha. At alpha position there is no substituent, but at beta position, look at this is a beta carbon atom, and beta carbon atom which has one substituent or one ring residue. Here you can write it here substituent. Alpha no there, but here is a beta. How many beta substituents are present here? There are only one beta substituent. You should add 12 nanometer in it. Now don't go this side. Why? Because there is no conjugation, no chromophore here. You should label this carbon. Next will be the gamma, and if you observe that gamma, is there any gamma substituent present here? Yes. Look at, there is a one ring residue, so there will be a one gamma. If one gamma is there, how much to add? You should add 18 nanometer in it, right? Now gamma, then delta. Look at delta. How many delta substituent present over here? If you observe carefully, you will find there are one is a alkyl group, one is a ring residue. So there will be 2 delta. 1 delta we are adding 18. So 2 delta means you should add 36 nanometer in it. And then now that's it. Then lambda max, and lambda max if you add perfectly, then you will find over here there is a 8 and 2 10, then 6 16 5 1. Now there is a 1 and 2 5 6 7 8 9 10 11 12. So now is a 2, then 1, and 1 and 2 becomes as a 3. There is a 321 nanometer. It is a answer for it. So in this way we can easily find out the what we can call it as a, in this way we can calculate the lambda max of any kind of the system. It may be diene system or enone system. We can easily calculate the lambda max of this type of the system. Now let me give one more example so that you will be now able to solve the rest of the problem on your own. So let us see one more example over here. Here is this one. There is problem number 8. Then C double bond O. This is a compound, which is the easiest compound I am written over here. Now let observe this structure carefully. What do you see over here? We know that there are the 2 systems. What type of the system present here? Look at here, carbonyl group and double bond. So there is a enone system present here. So you can write down here solution. So it is an enone system. It is an enone system. Once there is a enone system, there are 3 base values, 215, 202 and 207. Which one we should consider here? Look at this carbonyl group. There is a alkyl group substituent. So you should take the base value should be 200 and base value should be 215 nanometer, right? After that, what is the next point to do? There is a ring. Identify. Is there a ring present? Yes, there is a ring is present, a ring, and therefore, and put hand on A. What do you observe? There is no exocyclic double bond present here, so no need to write. Homo-annular. Is there homo-annular system present here? There is no homo-annular system. Now H stand for homo-annular, E stand for again as a extended conjugation. Only diene system, no extra double bond is present. So there is no question of extended conjugation. Now is a substituent. And as we know that this is a carbonyl group, adjacent carbon atom is termed as alpha. Is there any alpha substituent present over here? Yes, look at this is a ring residue. So substituent you can write over here, substituents. So there is a alpha substituent present. You should add 10 nanometer in it. Then next one, next carbon atom is termed as a beta, and that beta has a one substituent. So beta substituent you add 12 nanometer in it, and that's it. Then you can write here there is a lambda max total 7. So 1 2 3 and 2 is there, 237 nanometer. This is a lambda max. So in this way we can easily calculate the lambda max of any system. It may be diene system or it may be as a enone system. We can easily calculate the lambda max of those system. I think with this let us stop today here. Remaining we will see in the next lecture. Thank you. Have a nice day.